Good afternoon and welcome everyone on the next session titled Streamlining Data Governance from Traditional ML Ops to GenAI Ops. This session is a level 300 session and you are in the right room if you want to transform your GenAI projects from experimental playgrounds into enterprise-ready application with proper governance. Stay seated as we navigate the evolution from traditional ML Ops to the new world of GenAI Ops, where responsible innovation meets business value. It's my pleasure to welcome to stage Derrick Choo. Please give him a big round of applause.
Good afternoon, everyone. My name is Derrick Choo, and welcome to my session on data governance, streamlining data governance for GenAI, from traditional ML to generative AI. Today, although we're talking about data governance, I was actually spending more on governance for generative AI. Before we dive in, let me outline what we cover today. First, I'll cover the differences between ML Ops and GenAI Ops, and then we'll explore the governance challenges of GenAI Ops, RAG Ops, and Agent Ops. Finally, I'll give you a few implementation details on how you can actually address some of these challenges. And by the end of the day, I hope you can take away and build your own responsible AI systems and implement some of these governance frameworks in your organizations. To kick things off, I'd like you to imagine a traditional orchestra where each musician knows their exact piece and know what exactly they're playing. And the conductor's job is to ensure that each musician plays to the musical score. This is similar to ML Ops, where ML Ops is about understanding the data inputs, the model parameters, and we can predict the output with relative certainty. Now, imagine that same orchestra shifting to jazz improvisation. What it means is now musicians still need structure and guidance. However, now they are creating new compositions on the fly and responding to each other in real time. And the conductor's role shifts fundamentally from enforcing score rigidity to making sure there's a framework for them to embrace creativity while ensuring musical harmony. And this is where organizations who move from traditional ML to GenAI Ops are establishing frameworks that not just enforce rules, but implement safety guardrails to embrace innovation while ensuring responsible output. So let's continue our orchestra analogy to understand the key shift from ML Ops to GenAI Ops. In traditional ML, we are like orchestra conductors of classical music, where the score is well-defined, and we focus on selecting the right musician, data in ML, and perfecting the performance, model training. And governance focuses around the fidelity of the music, where we focus on the intent and look at prediction accuracy. And when instruments drift, we make sure that they focus back on the performance, model drift. GenAI Ops, by contrast, is application-centric. It is very similar to a jazz ensemble, where the focus is on governance around making sure where we put governance framework around governing multiple AI components. For example, like your retrieval models, your knowledge bases, and your agents, and making sure they collaborate together effectively. The governance challenges expand from: is the model accurate? To is the application behaving appropriately, safely, and effective? So, to govern GenAI application effectively, let me cover a few concepts on GenAI and understand the core architecture. The first one is RAG applications. RAG applications combine retrieval systems with generation, grounding their output in specific sources while leveraging foundational models. Think of RAG like a jazz musician who plays both the sheet music and the sheet music and does the improvisation and use the sheet music as factual grounding. Generative component is the improvisation part, where they create new content that flows naturally from these established themes. Governance must ensure both elements work in harmony. Agent application takes this a step further by implementing autonomous systems that plan action, make decisions, execute tasks using various tools and APIs. They introduce a new dimension of autonomy that requires governance. These are like self-directing orchestras that not only perform music, but choose their own repertoires, respond to audience reaction, coordinate other performers, without a traditional orchestra. As such, governing AI agents require frameworks that guide their autonomous behavior beyond output monitoring quality. Now, prompt engineering represents a unique governance that challenges that spans across both RAG and agent architectures. The first one is prompts. Prompts exist in a governance gray zone between code and content. They contain both algorithmic logic, yet they're written in natural language. This hybrid nature means traditional code reviews or content review process alone are insufficient. Take, for example, a financial chatbot, which may include a prompt instruction like speak professionally while showing empathy, alongside with a logical instruction like if user asks about loan rates, then extract the location and check out the regional rate database. And this is where, if you leverage traditional review processes, they may fail where engineers just focus on the logic and miss tone issues. The second challenge is prompts. Prompts can actually encode business rules, compliance requirements, and ethical guidelines. What it means is that now that whenever you make an update to your business rules, you need to ensure that your prompts are also updated as well, because these are crucial to actually avoid compliance and avoid legal exposure. Third, prompt injections represent a unique security threat where users can attempt to override system instruction through natural language. Fourth, without tracking experiments across hundreds of variations, teams can lose insights and duplicate failed approaches. The fifth challenge, version challenging extends beyond just text changes. Prompts often include dynamic elements that vary by user context, creating branching versions that traditional versioning systems struggle to track effectively. For example, a healthcare chatbot that uses dynamic prompts could include 5 different patient personas, 3 severity levels, and specialized instructions for 12 medical conditions, creating 180 possible prompt variations. As you can imagine, if I need to make a critical safety update, without versioning and experiment tracking, one can struggle to ensure all variations are properly updated and validated. 6, evaluation requires multidimensional metrics beyond accuracy. This includes things like tone, safety, brand alignment, and this can be difficult to standardize across multiple teams. 7, prompt drift can occur as model evolve, and this can cause subtle behavior that standard monitoring can actually miss. 8, collaborative behaviors emerges when prompt engineering knowledge are siloed. Without governance systems to share effective patterns, teams end up solving the same problem repeatedly over and over again rather than building on collective insights. So to address some of the challenges, I'd like to leave you with some ingredients for prompt governance. The first one is making sure you utilize a prompt library and template to ensure consistency across your application and eliminate redundant experimentation. The second ingredient, establish prompt version control for critical traceability in debugging and compliance. Third, it's important to have a comprehensive testing framework that validates your input across diverse output, identify potential edge cases before deployment to ensure they produce appropriate output consistently. Fourth, as I mentioned, security is important. It's important to implement security measures to prevent injection attacks, and this can be done through guardrails such as Amazon Bedrock guardrails. And fifth, it's important to standardize your experimenting workflow to systematically document your hypothesis, your methods, and your results for prompt variation to build organizational knowledge. And finally, as prompts can vary between logic and tone, it's important to establish a collaborative review process that brings together technical, domain, and compliance perspective when evaluating prompt performance. So how do you put this together to implement effective prompt management? So we begin with focusing on our developers, making sure they have a flexible and experimentation platform, using things like an Amazon SageMaker Unified Studio Playground, or Amazon SageMaker Notebook, or even their local development tools, or even their own runtime processes. And underpinning this is making sure you have a centralized prompt catalog so that you can implement version control, and where developers have a mechanism to publish their prompts and discover new prompts for reusability. Third, to transform prompt engineering from hypothesis to result, it's important to not just, as you run your evaluation, it's important to capture all your experimentation. And that can be done through a experiment server, such as Amazon SageMaker ML Flow. And what this enables is easy comparison between approaches and creating searchable history of what works and why. Fourth, it's important to have automation templates that use to facilitate consistent application packaging, evaluation, and review process to make sure they progress a pipeline from development to production. All these components should reside in a shared services account, enabling organization-wide access while maintaining separation from production environments. Now that we discussed how to implement governance, prompt governance, I'd like to give you a few options when it comes to prompt management. The first option is Amazon Bedrock prompt management. For Bedrock users, this is a really good tool, as it gives you out-of-the-box functionality to actually version control your prompts and test your prompts. Alternatively, if you're already using ML Flow, I would encourage you to look at using ML Flow server. However, make sure you know you're running version 2.21. And for Amazon, if you're going to use Amazon SageMaker ML Flow server, that's coming soon in version 2.21. We also have other partner options through the Amazon SageMaker Partner AI ecosystem. And finally, I see customers also using things like either using open source tools, their own third-party tools, or even building their own prompt management software. Typically, customers align their choices to their own technology tech stack and requirements. And most customers, they start simple. They start by using their own maybe a version control prompt, and as their use cases get more sophisticated, graduate to some of these more sophisticated prompt management tools. Now, we talk about prompts. Now let's look at some unique governance channels with RAG applications. The first one is knowledge-based management. This is critical because we need to answer questions such as, how fresh is your data? How do you update it? What process ensure content quality? Second, retrieval quality metrics are essential. We need to ensure we address common questions such as, are we retrieving relevant information? How do we measure and improve relevance? And third, citation and source attribution must be tracked, because this helps to maintain transparency about what information originated from. Fourth, as we talk about a RAG application, it's about doing retrieval and generation. And when you do the generation part, it's important to strike a balance between the retrieval and generate content, and clear field definition needs to be defined. Fifth, as you scale your knowledge-based application, it's important to have a knowledge-based workflow with clear governance. Why? Because we need to answer questions like, who approves the content? How is it maintained? And six, as we know, RAG application has evolved beyond just semantic search, and now encode things like using things like metadata. And that's why metadata governance becomes critical for effective retrieval. Quality retrieval depends on not just the content anymore, but how it's described, how it's organized, and having consistent ways of implementing taxonomy, tagging standards, and chunking strategy. Without proper metadata tagging governance, even the best retrieval algorithm will fail to surface the relevant information. 7, version control for knowledge artifacts is required to ensure tracking of available information at any point of time. Why? Because this creates an audit trail precisely to know what knowledge-based version was used for each interaction. And finally, for RAG, specialized testing methodologies are needed to evaluate both retrieval quality and generation appropriateness altogether. Now, let's explore how we can actually address some of these challenges in 4 pipelines that I actually defined here. The first pipeline is a knowledge-based data pipeline. And its role is to make sure we keep information current, relevant, and properly structured. In this pipeline, you should implement things like to put governance around chunking strategy, embedding model selection, vector data management, indexing algorithm, and metadata tagging. Take, for example, a healthcare company that might chunk medical documents as sections rather than arbitrary length to preserve context. Why is this important, you might ask? Because improper chunking strategy in such scenarios could separate symptoms from diagnosis, potentially leading to dangerous medical advice. The second pipeline I have here is retrieval pipeline that focuses on optimizing the fetching relevant information through the refinement of query embedding processes, input guardrails, retrieval method selection, and re-ranking strategies. Now, moving to the bottom right, there's the generation pipeline. And governance in this role is to ensure accurate, grounded response through model selection, contextual prompting techniques, post-processing validation, and output guardrails. For example, a pharmaceutical company might implement strict faculty checks when generating medical information, as they must match relevant clinical documentation. This addresses the balance between retrieved and generated content while maintaining response integrity. Finally, in the bottom left, we have the evaluation pipeline. And this is designed to provide you with a continuous improvement through representative data set of your real-world use case, clear metric definition, continuous automated evaluation, and structured the analysis of your results. Through this internet connect pipeline, this creates a continuous improvement cycle to help you address the key governance challenges of RAG. So how do you bring this into production with governance? As we know, RAG applications alone have multiple independent components, be it beyond just code. They include things like your knowledge base documents, your embedding models, your prompts, your guardrails. And all this must be captured in an AI registry to create an auditable application snapshot. And when it comes to bringing your application to production, it's important to have critical governance checkpoint to control and deploy and maintain clear accountability. For example, you might have a data scientist who will evaluate the technical outputs of a model and then hand it over to a governance stakeholder from legal, compliance, or business stakeholder to provide final authorization. This ensures both technical excellence and business compliance requirements are met. And as we move our application to production, one key thing to ensure is to achieve and maintain data freshness, as outdated information in RAG system can lead to incorrect, misleading responses, potentially causing serious consequences for your organization and customers. As we know, RAG applications depend heavily on knowledge bases, and as such, we need to implement what we call a data freshness protocol. What you see here is an example of how to implement one such example. What we have here is using an event-based trigger, where when data changes, and using Amazon Event Bridge, we trigger a data freshness protocol pipeline, which should do the data ingestion, put it into a knowledge base, run our test evaluation, and also document the version control of our knowledge base. And this helps to give you that clear traceability of your data as you get changed. Now, let's switch gears for a moment next now to agent ops. Agent ops introduce even more data governance complexity. First, comprehensive version control must document the behavior evolution of agents and maintain audit trails. Without these controls, organizations cannot ensure consistent agent behavior or effectively investigate unexpected actions. Second, agent access control for external systems is important through careful permission management, as we need to make sure tools are used appropriately while preventing unauthorized access to critical systems. Third, evaluation broadens beyond just accuracy. Now we're looking at things like reasoning quality and organization value alignment. Fourth, multi-agents introduce with multi-agents, we create exponential governance complexity, meaning we now require frameworks for agent communication and preventing undesirable emergent behaviors. Fifth, comprehensive monitoring becomes essential for responsible operation. We need systems that track the complete decision process of agents and not just the outcomes. Six, When it comes to the responsible deployment of agents, you need to have a controlled release process, and also have human intervention capabilities when agents do not do what they are asked. And finally, as you know, there's a lot of new concepts around MCP, agent to agent, and hence, governance must adapt as agent capabilities evolve. What worked yesterday may not be sufficient tomorrow. Organizations must develop flexible approaches and anticipate emerging risks while incorporating operational lessons. So before I dive deeper into agent governance, I want to do a bit of a breakdown on on the agent composition. First, agents can be composed of 5 key elements. We got your prompt, your model, your tools for functions, your configuration for controlling outputs, and safety guardrails. These structures enable governance at multiple control points, with all components should require version control to track changes, understand the evolution of it, and roll back when needed. And when it comes to tools, they can come in various forms. For example, you can have tools in code, APIs, and schema definition. And all this needs to be governed through fine-grained access control to make sure that they work appropriately. This ensures agents only interact with authorized systems in a predefined manner. And finally, as you actually implement your tools, it is important to have version control for your tool catalog as well. Why you ask this? Because you don't want your team to create the same tool for multiple agents. So when it comes to agent evaluation, let's explore some of the frameworks you can do to implement to ensure quality, compliance, and continuous improvement. Centralized to the approach, as you can see with RAG and prompt, there's a repeat pattern here, right? Here, what we have is talking about when you want to track that, we need to track the version of not just the agent, but all the different components in it to give you meaningful comparison and reproducibility. Next, for each evaluation run, it's important to capture both the metrics and trace information. You need to capture metrics that provides a balanced view of not just functionality, but also the user experience and quality. And for debugging and improvement purposes, detailed tracing is used to capture actions taken, decisions made, and revisiting paths. And while automated metrics are really great and essential, it's also important to leverage human evaluation from a diverse set of panels to provide insights for hard to quantify aspects of agents. And so next up, I want to show you a bit on how to implement agents for testing and release. So agent and testing and release is very similar to your DevOps process. And as agents do not coexist on their own, we're talking about agents working with other applications. Hence, it's important to establish well-defined testing pipelines that inject synthetic events to simulate real diverse user experience while capturing detailed metrics and traces. And it's also important to automate the validation outputs with human reviews as your ultimate promotion gates. This multi-layer approach thoroughly vets agents before user exposure. And as you roll out your agents to production, you should look at implementing things like A/B testing and blue redeployment. What this does, it helps you evaluate the agent behavior that synthetic environments cannot replicate. Each stage should include promotion gates where human reviewers evaluate and authorize wider deployment, allowing for early detection while gathering essential feedback. And finally, I'll talk about agent intervention. It's important to implement intervention mechanisms for human oversight. This could be achieved through things like setting a limit on agent retries and escalating to human to intervene when these limits are exceeded. Or intervening for high-risk action that are sensitive, irreversible, or have high stakes. For example, like canceling a user order, authorizing large funds, or making payment. This controls addresses key governance challenges by supporting thorough evaluation, providing safe release controls, and ensuring appropriate oversight. Now, we explored various governance challenges and implementation approaches with GenAI, and let's synthesize what we learned into some actionable best practices. So first, I'll say start with clear usage policies that define the boundaries of your application. Make governance concrete and actionable. Second, implement component-level monitoring rather than just end output checks. For example, RAG applications need visibility into retrieval quality, knowledge freshness, and generation accuracy. Thirdly, establish regular governance reviews with cross-functional teams. GenAI governance spans legal, security, product, and ethics concerns that no single team can address alone. Fourth, automate comprehensive testing that covers prompt variation, knowledge updates, retrieval quality, and security boundaries. Manual review simply can't scale with GenAI complexity. Finally, create feedback loops for continuous improvement, using monitoring data using user feedback and governance exception to refine your control and policies. By implementing these best practices, you'll be able to balance innovation with responsible use of generative AI. So, how can you get started? I'll say, first, assess your current application governance maturity. Ask yourself these questions. Do you have a clear usage policy? Have you implemented component-level monitoring? How are you handling cross-functional team reviews for GenAI? Once you know where your gaps are, implement governance measure. For example, if you have a RAG application, focus on knowledge management processes, retrieval metric quality, and source attribute tracking. Third, develop cross-functional governance processes, bringing together technical, business, legal, and security perspective. Establish an AI governance committee with clear responsibility and create documentation templates that integrate governance from the start and define escalation paths for exceptions. And finally, establish continuous monitoring framework using tools like Amazon CloudWatch to track both component-level monitoring and application-wide metrics with defined threshold for alerts and intervention. Remember that perfect governance isn't the goal. Effective governance is. Start with your highest risk application, implement pragmatic controls, and improve based on real-world experience. Organizations that take measured, systematic approach typically see faster and more successful GenAI adoption than those that ignore this. And to cap things off, and in the spirit of, I think, improvisation, because I talk about jazz and how orchestras move from traditional orchestra to jazz, and governance is not about perfection. I'm going to do a bit of a close-off, and I actually had this as a story to talk about music and how musicians have evolved from recorded music to embracing audience, and then how we should do it for traditional ML. But to give a twist, I'm going to do a bit of improvisation and close this off with a bit of a rap. So here goes with this, and yep, pardon me because this is my first time rapping, so I'm just going to do it. Cool. All right, are you ready for this? All right. Early 1900s, music got recorded. Conductors worried, thought their gigs were ended. Why see us live when perfection's on tape? But orchestras adapted, found a escape. From MLOps to GenAI, the shift is real. Governance ain't changed. It helps us steer. Structured meets freedom in the digital age. GenAI conductors stepping on stage. Don't cue the vibe, just guide the sound. Innovation flourishing, creativity unbound. Your framework's the rhythm, not a cage. Let GenAI improvise while you set the stage. You are the conductor, baton in hand. Time to orchestrate across the land. Make music that move, inspire, and grow. They are the maestro. Now steal the show, guys. Cool. Yep. Thank you, guys. And that's a wrap. And my name is Derrick Choo. And if you want to learn more, I'll be at the golf stand, the golf demo, showing you a real-world GenAI application. If you want, hit me up. And thank you all for coming.
A wonderful presentation, and thank you especially for the wrap. Please do take your time.